is Guillermo, and this is Kotlin Beyond Android. This is going to be the story of how I got to use Kotlin in new places after learning how to use Kotlin through building Android apps. Couple of disclaimers before I start. I try to have as little code as I can because all the code is going to be in GitHub. However, there's going to be a couple of slides with some code. I will try to walk you through it. If you go to my Twitter account, I have posted the slides already. So if it makes it easier for you to follow along, I'll recommend you to go there and check them out. You can also tag me in any pictures so I can show it to my mom. Make her proud. This talk comes with a lifetime warranty. What that means is like at any moment in the future, if you remember this ever happened, you can come to me and ask me, oh, but I think you were wrong here. I think we're ready to start. First, I want to say that I work for a company called Monzo. They paid for my trip to be here, so I guess it's cool to give them a quick shout out. Monzo is a UK bank that wants to make money work for everyone. We're a bit different from what we call legacy banks, in what we don't have branch offices, and all our users interact with us through apps. And that's what I do. I just spend my days building features to delight our users in our apps. We also recently launched in the US, both as a product. We launched a Monzo account as a beta product. But we are also launching engineering in LA. We're hiring backend iOS and Android. If you want to be one of the first Monzo engineers in the US, reach me out. Catch you later. But back to the point of this talk. I'm here to tell you a story. And this story begins with Android. I've been doing Android for quite some time. And I gotta say that I love doing Android, but mostly because of the community. I think the community is quite open, welcoming, supportive. If you ask to any of your workmates that happens to work in a different platform, say iOS, we are the envy of other platforms as a community. I think we should be really proud of that. We have been through a lot together, some hard moments, but also some very exciting ones. And I know this is after lunch, so maybe you're a bit sleepy. So let's play a quick show of hands game, shall we? So who remembers the day that official Kotlin support was announced? Wasn't that exciting? Very exciting. That day marked the start of a very, very nice journey in which we came back home and we started throwing shortcuts to convert all our files to Kotlin. And as the time went along, we started writing more Kotlin and understanding Kotlin better, me included. And then one day, I wonder, I've been putting Kotlin into phones, Android phones, for a while, but Kotlin was not invented for Android phones. It existed before. Is there something else that you can do while doing Kotlin? And then you keep thinking. So I'm a mobile developer. I daily interact with some kind of service. You can be uploading, downloading, streaming, reporting, tracking. You're going to interact with some kind of external service. So I thought maybe I can write some of that server code in Kotlin as well. So I started looking for how to write Kotlin in the backend. And if you go to the Kotlin documentation, there's actually a section about it. And they will mention several frameworks, like you can write Kotlin for Spring, or you can write Kotlin for Vertex. But they all have one major flaw, is that their name doesn't start with K. And we know like it's mandatory for Kotlin libraries to start with a K. So I went with Ktor. In all seriousness, Ktor was my choice, also because Kotlin supported Score to it. It was built by JetBrains, trying to showcase the strengths of Kotlin in the server side. Of course, you can write Kotlin to any framework that runs on the JVM. That's part of what makes Kotlin adoption easy. But Ktor is built for it. And it makes very heavy use of features such as coroutines and typeset builders. So this is how a hello world in Ktor looks like. Very simple, can remind you of some JavaScript frameworks, but there's not much fluff around. There's no defining beans in XML, or there's no configuration files that are endless text. And we all know like hello worlds can look very pretty, but Ktor keeps being expressive when the code you start building starts to get more complex. Say you want to include OAuth in your server application. OAuth is a very complex flow, but Ktor allows you to do it really easily, thanks to one of the companion libraries it comes with. It also has companion libraries for things like templating or authentication. That's all great, but many server frameworks have that kind of ecosystem of libraries. One of the things that really impressed me were the way of doing tests in Ktor, specifically API tests. So you can think of your code running in, let me start again. So you can think of your tests as running against your production code, but this is a server, so there's a lot of things involved in making a request. There's HTTP headers, you need to open sockets, you need to do a lot of things. Ktor tests remove all of that and introduce you to some concept like a test application. In that test application, you don't create any web server, you don't bind to any sockets, and you don't do any real HTTP requests. You run against your code directly. So when I'm doing handle request, I'm simulating a request to my whole stack of server code, and then I'm asserting over the response. This has some benefits, like it's very fast to spin up, and you can do real unit test speed at the expense of maybe missing out on testing some particular things on HTTP headers. You may think about it similar to how Row Electric mocks the framework, the Android framework, but actually faster. Then you have your server code, you have tested it. So what do you do with it? You have to deploy it. It's a backend service, and there is no Play Store for backend apps. You need to find a place for your code. The place I found was Heroku. Heroku is a platform as a service that lets you run services just by pushing to GitHub. You will need to define which command needs to run your server, but additionally, because you are shipping source code by git push, you need to define how to build it. Once you have done those definitions, you can just simply git push to a different remote, which is Heroku. And that will generate a ton of text in your push message, more text than you're used to. It actually will generate the whole bin thing. But at the end of it, it will do some sanity checks and replace the running service with the latest one. That's great, but that introduces a problem. Now you have two places to push to. And all that pushing to master got me a bit worried. Like, it doesn't feel right. So I set up my project in a CI service. I used Circle CI because I was more familiar with it from Android development. And I added a step to deploy to Heroku every time there was a new commit in master. So everything that I had to do was simply push into one branch, my GitHub branch. That will trigger a Circle CI build. And if the build succeeded, then continue to the deployment task. All the code for that you can find in the GitHub repo under the backend folder. So great, now I have a server set up. Simple, right? Why don't I build a web client? And when I say web, what do I really mean? I already have some piece of code in a server that that returns some JSON given some path. All I need to do is really make it return some HTML in a different path. Can we do that with Kotlin? Of course we can. There is a DSL for Kotlin that allows you to do HTML, because there is a DSL for everything. You can use it server-side to render HTML, do some templating, make some dynamic pages. You can think of a nicer way of doing PHP. The problem with this is, like, really quickly, it turns into a big mess. You ended up having massive Kotlin files that is really, it's just HTML, but you replace the angle brackets with curly braces. Have you gained anything? So then I discovered React. React is a very popular UI and state management framework. It's really popular in the web. It allows you to build component-based reactive UIs. I wanted to use React just to try out, but I had a problem. React is not JVM compatible. React is coded in JS. And I need to take a step back here. So in traditional Kotlin, or Kotlin for the JVM, and I am simplifying this a lot, your source code goes through the Kotlin compiler, and at the end, it produces class files. Class files are the files that contain bytecode that the JVM understands and runs. That's all great, but that's not compatible with React. So enter KotlinJS. It's a different Kotlin compiler. And in this compiler, your code, instead of being compiled to JVM class files, it compiles into JavaScript or transpiles, depending on how picky you are. It's a compact and minified version of the JavaScript, but you can actually go to the file and read it, and it is JavaScript. And that JavaScript can run in a browser or a compatible engine like Node. So you can write something like that, and it's actually accessing the DOM APIs and all other JavaScript libraries that you may install. But it introduces a problem. Some of you may already have spotted it. Like, how is this possible that Kotlin, a language that is known for its very robust type system, interacts with JavaScript that is, well, JavaScript? And there is a secret to that. The secret to that is a dynamic keyword. So dynamic is the kryptonite of the Kotlin type system. It will deactivate it completely. Whatever you put dynamic at, you're just telling the Kotlin compiler, never mind the types, trust me, I know what I'm doing, hold my beer. That can be useful when interacting with JavaScript, but it can be also really dangerous. Like, you can write things like this, and the compiler will be okay with it, even if it makes zero sense. Because the compiler is trusting that you said, you know what you're doing, fine. But this will blow up in runtime horribly. However, this is needed to interact with certain JavaScript APIs that are not well-defined in type-wise. Then you can downcast it to save types in your code and keep working normally. So fine. So I'm already able to emit JS. And I am able to use React. And of course, there is another DSL for React Kotlin. You can use type-safe builders, and you can achieve a type-safe React, which is a really nice experience. It still suffers a bit from this problem of you just end up writing React, but with curly brackets. But it has some benefits, because since you're dealing with state management, the type safety, it's very nice. You can also find more details of this and in the code in the web module of the project. So I have a backend, an app. I have a web just because I can. So doing things just because I can, you may think, why not build an iOS app? Like, is that even possible? The answer is yes. Because there is another Kotlin compiler, so many Kotlin compilers. This one is Kotlin native, and it will take your Kotlin code, simplifying again, transform it into an intermediate bytecode, which is compatible with LLVM. What is LLVM? LLVM is a compiler infrastructure that is used for languages for the C family. So C, C++, Objective-C. And just incidentally, it's the same infrastructure that iOS uses. What this means is that we can run Kotlin code and compile it to be used in iOS. If you tell the Kotlin native compiler that you want to use it in iOS, at the end it will produce something called a framework. A framework is how iOS developers package and reuse modular code. So it's like having an AAR or a jar file. And it will allow you to import it into your iOS project and call it from there. However, this doesn't save you from actually having to open Xcode and having to write some Objective-C or Swift. You thought that Eclipse was bad? Try Xcode. On the other hand, Swift is a very cool language. It's coming from Kotlin, it feels very familiar and it feels home. There's even a whole website dedicated to show how Swift and Kotlin are basically the same language. Also, there is some additional tooling, like you don't have to do all the dependency management by hand. There's something called CocoaPods, which will be similar to how Gradle resolves dependencies. And it's embedded into the Kotlin native Gradle plugin. There is also some really nice tooling provided by TouchLab that will allow you to debug Kotlin code in Xcode and sync your Kotlin files so you can see them from the Xcode. So you don't have to be swapping IDs back and forth all the time. All of this makes working with Xcode a little less terrible. So in some ways, this collection of different toolchains I was talking about, you could just call it Kotlin multi-platform because it's running Kotlin in different platforms. But when you say Kotlin multi-platform, you actually mean a bit more than that. The term is a bit overloaded. When you talk about Kotlin multi-platform, you also talk about multi-platform modules. So multi-platform modules is a term used to describe a special kind of Kotlin Gradle modules that are made to work with a different kind of source sets easier. That was a mouthful. I will try to show you what I mean. So by applying the right plugin at your module configuration level, there will be new source sets created. There's one special one called Common. And this one is special in that the kind of Kotlin you can write there is very restricted. You cannot use any platform-specific features. You cannot use things like synchronized, or you cannot use things as dynamic. But there's a good reason for that. It's restricted, so it can actually be included in the compilation unit of all the other different platforms. Then with the multi-platform plugin, you can configure a JVM target, an Android target, iOS target, JS target, some native targets. In the latest release, you can even compile to Watch OS. You can also have like test targets, and these test targets will include their main target. But I will focus on the main code for now. You just have a structure that allows you to reference common code from the platform's specific code. That's great, but that's only one direction. What if you need to, in your common code, reference something that will be implemented later in your platform-specific code? You could have interfaces. Some people advocate very strongly for interfaces. You can have wrappers in the case that there is one interface that has to be implemented by different libraries. But you don't want to rewrite everything in common. Like, you don't want to write all the features that you have been depending on libraries for in your common code. So there is some new keywords that allow you to do something a bit different. So these keywords are expect and actual. You can have an incomplete declaration of some sorts in your common code, but just say that you expect it to be completed down in your platform-specific code. So you mark that declaration as expect. The rest of your common code can reference that expect declaration and work with it normally. Then once you are in your platform-specific code, then you mark your source code with actual. This is an actual implementation of that expected declaration. What that does is, like, when you target say Android, the Gradle plugin will take your common code and your Android code and it will fill up all the expected holes that finds in the implementation, and at the end will produce an AAR, and the consumers will never notice. So congratulations, you have achieved code sharing. But code sharing is not just on the multi-platform plugin. There are a lot of multi-platform libraries, some of them made by JetBrains, some made by the community, that help you through this journey. Because again, you don't want to re-implement everything, and common is restricted to only depend on common code. So how do you serialize things? So the Kotlin serialization library makes it really easy. You just put serializable annotation on top of your data classes, and that will work in all the platforms because they have per platform implementations. Building on that, once you have serialized or deserialized the data, you may have to submit it or fetch it. So Ktor actually is not only a server framework, it also has several client frameworks that delegate to different implementations in the different targets. For instance, you can have an HTTP client in your common code, and in Android that will delegate to the OKHTTP client. In JS, it will just use the DOM native fetch API. But it lets you write platform agnostic data fetch, which is very nice. And then what about asynchronous operations? Well, there is coroutines, and coroutines have been built in multi-platform way. It's supported, but there are some caveats. For instance, in Kotlin native, say iOS, it's only supported in the main thread, really, with the current implementation. You'll need some workarounds around it. So, for instance, you might need to define custom scopes. And there's work being done at the moment, nevertheless. So, with the 1.360 Kotlin release, there was a developer preview for multi-thread coroutines. So, that's quite exciting. So, code sharing for some is like the holy grail of multi-platform development. And actually, if you look really, really well at the Kotlin documentation, it's explicitly stated that it is one of their goals. It was there all the time. We just didn't see it. But with code sharing comes the hard question, like, how much do you share? Where do you draw the line? It very depends what's your case. And you may be able to divide, say, a client app in layers like this. You can have your network layer, your repository layer, some domain logic, some presentation logic, view banding, and UI. I will strongly advise against sharing anything that has to do with UI and view binding, because then you are no better than React Native. But for instance, say that you want to draw the line here, network and repository. Why would you want to do that? Well, maybe you have a very specific and complex way of accessing your network. You may be using protocol buffers over sockets over pigeon carrier. And that's very specific to you, and you want it to be implemented uniformly across. You also may have like a very specific or exotic mapping on your repository. Doesn't matter. Your apps will just see that network library and interact with it like they interact with any other library. And you can draw the line there and be happy ever after. You can also push it a little bit and say, I'm actually gonna not only share the domain logic, but also the presentation logic. I tried this way. This is the way like I tried it in my project. And it works, but probably because it's a pet project. Let's be honest. If you think about it, your UI needs to be quite consistent between platforms. It doesn't need to be the same, but you are tying the presentation logic together. It requires careful planning of the API changes. When I say API, it's the API of your presentation layer, because then your UI layer has to follow along. But hey, it can be an extreme way of making sure that both platforms are in sync. So with all of that, onto the present, what do I have at the moment? I have a backend up and running, exposed to the world. You can see URL to it. I have a website that accurately reflects my passion for graphic design. And I have a couple of hubs that are very simple, but they share everything up to the presentation layer. I'm gonna say that as an absolute boom because you can check it out in GitHub and it runs, it works. But onto the future. What does the future hold for my project and for us if we're interested in multi-platform? And this is kind of cheating because 1.360 was released last week. I just didn't have time to investigate deep down. But with 1.360, a lot of new progress has been made into multi-platform. Mostly in Kotlin native. Like Kotlin native now supports targets like Watch OS, but it also supports targets like Android native. And hear me here, because native is like repeated a lot during this talk. But what I say Android native is that the Android NDK. So you can actually target the same C-style APIs in iOS and Android if you wish so. They also added some symbolication of iOS crashes. What that means is like when an iOS app crashes, it's native code. So it needs some way of reconstructing what happened there. This is similar to, say, when you upload your program mapping files. And JetBrains claims that their symbolication is better than Apple's. So there's something to check out there. They made a ton of performance improvement. Even then, they say that this is not yet performant, but it is noticeably better. And there is a new JS plugin that intends to replace the current plugin. I am yet to be successfully replacing it. It's still not easy, but they have made some improvements there. And they already mentioned multi-threaded native coroutines preview. But even fresher from the oven, like literally last night, I was talking to some other speakers, and we came to the idea of what if we could have a multi-platform architecture. And by this, I don't mean sharing code, but sharing the architectural language. Like when I say screen, everyone understands the same thing. When I say coordinator or flow, everyone understands the same thing. And then Kotlin multi-platform just becomes an implementation detail of that architecture. So stay posted. So wrapping up, the $1 million question: is the tech ready? It depends. You can argue a lot about API stability, that all the things are subject to change. The ID compatibility is breaking every now and then. It becomes a bit of an uphill battle, and one that I had to fight on my pet project in my free time, so it was even less funny. You can also criticize the runtime model of the runtime memory model of Kotlin native. Many people have done it, but I think the best thing is that you just judge by yourself. You should try it out and see if it really fits you. So that's why I'm here sharing all of this, and why I make it open source. Like, I don't want to bash you with a bunch of code in some slides that you will forget tomorrow. I want you to go and check out the website, the beautiful website that is live there. I also want you to check out, I'll wait for your picture, don't worry. I will wait you, I want you to check out the code. So this is all the code of the project I've been talking about. But even more, like I was thinking, I've made all this progress in these different non-obvious tasks. What if I provided a template that you can just use? And so you can go to this repo, you can check it out, you can fork it, or like, since it's a template, there will be a button that says create a new project with this template, so you don't have to keep my lame history. But you go there, fetch it, build something, judge by yourself, try it out, give it a spin, and see if it really works for you. And then let's have a conversation about it. Here are some links. These are the links to the slides, code templates, and my Twitter account, in case you want one picture with all of them. I'll wait, don't worry. I know how annoying it is to take a picture and then the slide moves. I've been there sitting. Okay, everyone got the picture? Fine. So before Q&A, I actually want to give you something back, because I had to do some small promotion of Monzo, but it's not for nothing. So I mentioned Monzo beta launch in the US, and you can download the app, but there is actually a wait list. You have to wait until you're promoted from a wait list. If you want to skip the queue, I have something for you. This is a golden link that we call that. This will let you bump the queue and be one of the first ones to receive your freshly minted account, just as a thank you gift for coming here to my talk. So with that, if you have any questions. Yes.